Very good morning, students. Today we are going to see the topic of optical path. In this lesson of optics, the optical path is nothing but optical path of a medium is defined as the distance d dash light travels in vacuum, the same distance it travels as a distance in the medium. So simply tells us when the light travels in vacuum, it covers some distance. At the same time period, the light travels in a same distance but in the medium. So here consider a medium of refractive index n. So n represents refractive index and d represents thickness and v represents velocity of light travels with the medium at any instant time t. So we can write as, we know that velocity is defined as a rate of displacement with respect to time. So we can the distance will be covered at d at time period t. So we can rewrite the equations. So changing this the terms of v and t. So we get the t value from this equations. So t becomes d by v. The same time, the another way, the light can cover a greater distance in vacuum. So because of light travel very faster in vacuum, so we can tells us a light can be greater speed in vacuum. So same way, velocity of light in vacuum we can represent as c. Velocity of medium we can represent as v. Here velocity of light in vacuum, so d dash by t. So same way we can rewrite this equations. T becomes t dash by c. Here simply notice that t equal to d by v, and then here t equal to d dash by c. So both our left hand side must be same, so we can equate the terms of right hand side. So first term becomes t dash by c equal to d by v. So rewrite this form of the optical path. We can measure the value of optical path d dash. So we get the value of d dash. This equation goes to here, c into d by v. So already we know that n tells us refractive index. So refractive index is nothing but velocity of light in vacuum by velocity of light in medium. So c tells us vacuum, which means velocity of light in vacuum. V tells us velocity of light in medium. Okay. So the optical path d dash defined as, which means the equations comes from this by using this refractive index term. So d dash equal to c by v. Here c by v can replaces refractive index and d. And finally, the refractive index always greater than 1. The optical path d dash of the medium is always greater than d, which means vacuum space is greater speed when compared to medium. In second topic, refraction. In this case of refraction, when we are doing the process of refractions, this must be having of two medium, but reflection having only one medium takes place. So first of all, when the light passes from one optical medium to another optical medium through a boundary, a certain boundary, in a refraction of angle of incidence, we know that I represent as angle of incidence of one medium. In our be the angle of reflection. Notice this point, angle of reflection in the other medium. measured with respect to the normal drawn of the point of incidence. This is called as law of refraction, which means Snell's law. So the Snell's law is important one. The first statement of Snell's law: the incident ray, refracted ray, is normal to the refracting surface or lie in a coplanar. Coplanar means is nothing but lie in a same plane. And second point, the angle of incidence I in the first medium to the angle of reflection or in the second medium is equal to the ratio of refractive index of the second medium n2 to the refractive index of first medium. So angle of incidence is related with the refractive index of a second medium, and reflection related with the first medium, which means refractive index of a first medium. So we can write these equations like this: sin I by sin r equal to n2 by n1. So the above equations we can rewrite as in the formations of product form. So n1 sin I and n2 sin r. This is the refractions of light. A simple note on given on our book. We need a point. In normal incidence of light on a surface, the angle of incidence is 0, which means this is the incident point of the light. So incident is here, so the angle of incidence must be 0. And further, we are going to see angle of deviation due to refraction. A simple topic. We know that angle between the incident and deviated light is called as angle of deviation. When the light travels, note the point, when the light travels from a rarer medium to denser medium, which means rarer medium to denser medium, it deviates normal to the line joining of the surface. On the other hand, it's similarly opposite. The light travels from denser to rarer medium, it deviates away from the normal. Here, show the figure. Simply notice this. First point, when the light enters from rarer medium to denser medium, if deviates towards the normal, this is normal, towards the normal. So angle of deviation due to refraction from rarer medium to denser medium towards the normal. In second case, this is an incident ray, which means this is a denser medium, this one is a rarer medium. So when the light enters from denser medium to rarer medium, so it deviates, which means away from the normal line. This is normal line, the second line is away from the normal line. So angle of deviation due to refraction from rarer to denser is towards the normal. Angle of deviation due to refraction from denser to rarer medium is away from the normal, towards here, away. Okay, good. So this point will be provided in the characteristics of refraction. First point, when the light passes from rarer medium to denser medium, it deviates towards the normal in the denser medium. First point already we have seen in the diagram. Second point, when the light passes from denser medium to rarer medium, it deviates away from the normal to the rarer medium. Second point, this. And third one, in any refracting surface there will be also some reflection taking place, which means reflections and also refractions taking place here. Thus the intensity of refracted light will be less than the incident light. So the phenomena in which point of light from a source undergoing reflection and other part of light from the same source undergoing a refraction at the same surface is called as simultaneous reflection or simultaneous refraction. This is incident ray reflected in this process is refracted. Reflected takes place in single medium, which means same medium. A refracted have a two medium, which means 1 and 2. In the another topic, principle of reversibility, it may be asked in 2 more questions. So principle of reversibility is nothing but when the light passes some way, it will be follow exactly the same path of its directions its travel is reversed, which means when the light passes here and incident on the reflecting surface after reflected, the same process when the light passes, which means incident on a normal surface of the reflecting, and then after reflections takes place here, the same process incident ray here passing the opposite direction, which means ray traces is reversed. This is called as principle of reversibility. The first one diagram, which means A diagram, tells us reversibility of reflection. Here reversibility of refraction, because of they have using only one medium, here two medium, which means rarer to denser. Next we are going to see the topic of relative refractive index, which means it's depending upon the one medium to another. From the equations of Snell's law, the terms n2 by n1 is called as relative refractive index of a second medium with respect to the first medium. So we can denote it as n21. So n21, n represents as refractive index, 2 represents as second medium, and 1 represents as first medium. So we can tell us simply refractive index of second medium with respect to first medium. So n21, the first term will be write as in the numerator. So n21 equal to n2 by n1, refractive index of second medium with respect to refractive index of a first medium. So the concept of relative refractive index gives rise to other useful relations such as inverse rule and chain rule. So inverse rule, n12 is nothing but a refractive index of a first medium with respect to second medium. So we can write as n21, the first term, n1 by n2, or otherwise we can rechange as 1 by n21. So reciprocal of the value it gives of 1 by n2 by n1, the terms will be, we get it, chain rule. The same way we can using the process of chain rule. N32 is nothing but a refractive index of third medium with respect to the second medium. So we can write as n31 and which means multiply n12, we can write as n31, n3 by n2, and n12 becomes n3 by n1 into n1 by n2. This is this one and this one is here. Okay, good. In the important one more topic of, it may be asked in 5 mark or 3 mark questions. Apparent depth. Apparent depth is nothing but we can see this process in our day-to-day life, like us. Everyone show visit us hotel. So in front of the cashier, they having a glass bottle kept into be a lemon on the water. So the size of the lemon suddenly rises in the bottom surface of the water when compared to the upper surface of the water, or otherwise in case of this is the lattice. So we are placed in a glass slab and the lattice. சிம்பிளாக சொல்கிறேன்ப்பா, அதாவது நம்ம ஹோட்டலுக்கெல்லாம் போகும்போது என்னென்னா, இந்த கேஷியர் அதை கவுண்டருக்கு முன்னாடி ஒரு கிளாஸ் பாட்டில் மாதிரி வச்சுருப்பாங்க. அதில் பாருங்களேன் ஒரு லெமன் போட்டு வச்சுருப்பாங்க. அந்த லெமனில் 2 மீடியம் இருக்குது பாருங்களேன். கிளாஸ்க்கு மேலே ஏர் மீடியம் இருக்குது, கிளாஸுக்கு கீழே விச் மீன்ஸ் அந்த வாட்டரில் பார்த்தீங்கன்னா வாட்டர் மீடியம். அப்போ 2 மீடியம் இருக்குங்களா. அந்த லெமனை நம்ம இன்சர்டட் பண்ணும்போது இந்த பாட்டம் ஆஃப் த சர்ஃபேஸ் ஆஃப் த லெமன், தண்ணிக்கு உள்ளே இருக்கிற அந்த லெமனுடைய சைஸ் கொஞ்சம் என்ன ஆகுனா பெருசாக இருக்கிற மாதிரி இருக்கும். இட் மேபி லிட்டில் பிட் ரைசஸ். ஓகேங்களாமா. அப்படி அதுக்கப்புறம் அடுத்த ப்ராசஸ் நம்ம பார்க்குறோம். நெக்ஸ்ட் ஒன் எப்படின்னா சார்னு சொல்லும் பார்த்தீங்கன்னா, இந்த லட்டஸ் மேலே ஒரு கிளாஸ் ஸ்லாப்பை நான் வைக்கணும்னு வச்சுக்கோங்களேன், டிரான்ஸ்பரண்ட் கிளாஸ் ஸ்லாப். அந்த லட்டஸோடைய ஹைட் என்ன ஆகி இருக்குன்னு சொல்லும்போது அப்படின்னா ரைஸ் ஆன மாதிரி இருக்கும். இன் அதர்வைஸ் பாட்டம் ஆஃப் த டேங்க் நம்ம பார்த்துருப்போம். அந்த டேங்க்கோ அப்படிலாம் பாட்டம் ஆஃப் த பாண்ட், இந்த குளத்தில் என்னங்கன்னா நம்மளுடைய ஃபுட் ஃபீட்டை வைக்கும்போது நம்மளுடைய ஃபுட் ஃபீட்டோடைய அந்த சைஸ் கொஞ்சம் என்லார்ஜ் ஆன மாதிரி ஒரு ஃபீல் க்ரியேட் ஆகும். ஸோ அதை கூட நம்ம என்ன சொன்னால் அதுக்கு பேர் தான் என்னென்னா இட் மேபி அப்பேரண்ட் டெப்த். ஓகேங்களா, அதான் இங்கே கொடுத்துருக்காங்க. இட் இஸ் காமன் அப்சர்வேஷன் that the bottom of a tank filled with the water appears rises. So an equations could be derived for the apparent depth of moving in the near the normal direction. So first diagram will be provided here and we can be explained in the second diagram as a derivation form. Here OP the bottom of the tank, the light passes from denser medium to rarer medium. Here we are taken as denser medium like water and rarer medium takes air. So when the light passes from denser medium to rarer medium, it deviates. Clearly note the point. When the light passes from denser medium to rarer medium, the light deviates. This is normal. The light deviates from the normal incidence. So the point B deviate from the point, which means the incident ray meeting at the point B, then after deviates from the normal line. Hence again N1 represents refractive index of denser medium and N2 represents refractive index of rarer medium. Here N1 is greater than N2. So I be the angle of incidence in the denser medium, in R be the angle of refraction in rarer medium. Okay, here n dash, listen here, n dash and OD, which is parallel to each other. The angle of DIB, the angle of DIB is also or. The angles I and or is very small from the diverging light entering the eye very narrow. This. So by using of Snell's law, the product form we can write as here the refractive index of N1, here the refractive index of N2. Here I be the angle of incidence, here or be the angle of refraction. So we can write as this form by using the diagram. N1 I, N2 R. So N1 sin I and N2 sin R. As the angle of I and R very small, we can approximate sin I similarly equal to the tan I. So we can rechange these equations. 6.19 N1 sin I replaces as tan I, so we can write as N1 tan I equal to N2 similarly sin R replaces as tan I here using of I, so we can know that Snell's law according angle of incidence which is equal to angle of refraction. So we can write as n1 tan I and n2 tan I. And also using this we can write changes tan R, no problem. So the triangles of DOB to provide calculate the value of tan theta equal to tan I equal to opposite side dB and adjacent side du. So tan I written as dB by du, and tan R, the another angle GIB, tan R, opposite side dB and adjacent side GI. So here, so put the value of tan I and tan R in this equation. So n1 tan I becomes here and n2 tan R becomes here. The both sides we have the same component of dB, so neglect the terms of dB. And dB's cancel both sides, we know that. And DO is actual depth of D and DA is the apparent depth of D dash. So N1 DO tells us actual depth, so we can write as D, and N2 apparent depth DI, so we can rechange as DI becomes D dash. So we can write as N1 by D and N2 by D dash. So we calculate the D dash value, which means apparent depth. So D dash into D. So we can rechange these equations. N1 by D equal to N2 by D dash. So D dash goes to here and N1 goes here. So the terms comes from D dash by D, then after N2 by N1. So rearranging the equations to calculating the apparent depth D dash. So we get D dash equal to N2 by N1 into D. This is, so put the value of refractive index of a second medium becomes 1 because of the rarer medium air and its refractive index taken as 1, and refractive index of a N1 is of a denser medium could be taken as N1 becomes N, which means N1 taken as N and N2 taken as 1. So the equations comes from D dash equal to D by N. This is. So finally, the bottom appears to be elevated by the D minus D dash. So same D minus D dash, we can calculate the value of D dash already. So D minus D dash becomes D by N. So this equations comes from D minus D dash equal to D into 1 minus 1 by N. This is of the apparent depth. Next topic, and one more important topic also, critical angle and total internal reflection. In this case of when the rays passes from optically denser medium to the rarer medium, it bends away from the normal. We know that when the light passes from denser to rarer, it deviates away from the normal because of this angle of reflection refraction or on the rarer medium is greater than the corresponding angle of incidence. As the angle of incidence I is gradually increased and also or rapidly increase, in certain stage it becomes 90 or grazing the boundary, which means like that when the light is travel from which medium to which medium, denser medium to rarer medium, the angle of incidence, this I, this is angle of refraction. When we are increasing the angle of incidence and the refracted ray slightly increases over the boundary, this is on a boundary line N1 and N2. So this is called as the angle of incidence of the denser medium, which of the refracted ray, incident ray here, this is refracted ray here, graces over the boundary. This is the boundary line of two medium, which means water medium and air medium. So the refracted ray crosses over the boundary line. This is called as critical angle. And further, the angle of incidence increases in denser medium. Beyond the critical angle, there is no refraction process. See here, there is no refraction here. So when the light enter reflected back into the denser medium itself, we are passing the light in the denser medium, and also the reflections takes place in the denser medium, not in radar medium. So this is called as total internal reflection. So what are the conditions to take place of total internal reflection? This is the important point. The light must be traveled to denser medium to rarer medium, most important one. An angle of incidence in the denser medium must be greater than critical angle here. So by using Snell's law in the form of product form, n1 sin Iz, n1 refractive index sin Iz, which is equal to n2, or becomes sin 90. So sin 90 becomes, we know the value of 1. So n1 sin Iz equal to n2. We calculate the critical value of Iz. So critical angle, sine of the critical angle Iz becomes n2 by n1 here, n1 greater than n2. So put the value of n2 becomes 1 and n1 becomes 1. So sine Iz equal to n2 becomes 1, so we can write as 1, and n1 becomes n. So the critical angle of incidence Iz equal to sine inverse of 1 by n. This is the refractive index of a glass. So the value of refractive index of a glass about 1.5. The angle for glass of interface is 41.8. So this is an important tabular column to know the value of refractive index and critical angle for different media. And finally, we are going to see the topics of effects of total internal reflection. The first point, glittering of diamond. How do the diamond can glitters? Diamond appears dazzling because the total internal reflections of light happens inside the diamond. The refractive index of a diamond is about 2.1. So this is the most value of higher. It is much larger than any other ordinary glasses, which is about 1.5. The critical angle of diamond is about 24.4 degree. It is much less than diopter than glass. So a skilled diamond cutter makes use the large range angle between of incidence 24.4 degree to 90 degree. And the last one more topic, mirage and looming. Here, mirage. The refractive index of air is increases with density. So refractive index increases and also increases its density rho, which is also directly proportionality. Here hot air is less dense, which means in the hot places it is considered as a hot places. The hot places, air near the ground is hotter. Air near the ground is hotter when compared to the some height. So hot air has less density. Still, the refractive index of air increases with height. The refractive index of air increases with height. So this is a higher value of refractive index when compared to the near the surface of the earth. Because of this, light from the tall objects like a tree passes through the medium whose refractive index decreases towards the ground, which means when the light entering from the height, this is a refractive index value of higher, so slightly decreases and reaches the near the surface of the value, the refractive index becomes lower or decreases towards the ground. The same way, the total internal reflections undergoes when the angle of incidence near the ground excess of critical angle. So it increase, which means excess of critical angle is must be produced of total internal reflections takes place. This phenomena is called as mirage. In other case, in otherwise, we are taken as cold place. The cold place refractive index increases towards the ground because the temperature of air is close to the ground lesser than the temperature of above surface. So the density of the refractive index near the air is greater than height. In cold regions like glaciers, frozen lakes and seas, the reverse effect of mirage will be happen and this inverted image formed little. So above is called as looming. This one is. And finally, prisms making by using of total internal reflections. So prisms so can be designed the reflect of light by 90 degree or by 180 degree making use the total internal reflections. See the figure. The first two cases, the critical angle IZ, critical angle IZ. The critical angle IZ for the material of the prism must less than 45 degree. Here we see the table already 6.3. Flint glass is having the refractive index value something, and also prism also used in remote images. We can changing the size of figure. This is how we can making of prisms by using of total internal reflection. So okay, good students, if you have any doubt, ask in doubt clearing classes, and also we can be asked in a Zoom live class. Thank you so much.